Okay, hello, welcome to another case walkthrough. Today, been looking at this case called At the Races, which was one of the Road to Las Vegas cases from 2023. So coming up to 2.5, 3 years ago, so quite a bit before my time, but an interesting case. So it's basically the basic setup. Again, I'm assuming if you're watching this, you've either done the case or you're going to do the case, but just for context, so we've basically got a racetrack represented by these different coloured cells and the letters inside them, and we've basically got a bunch of questions that kind of mimic mocking up racers going around this track and being affected by whether they're on a straight, a turn, whether they got a power boost, whether they're going through the pits or not. So kind of looks a bit like a map, although I wouldn't say it's a traditional map case really, because we just need to understand how to manipulate this data and turn it into something useful. As this is an old case, so it's 5 levels, 3 bonuses, but still 1,250 points. The first time I did this, I got stuck on level 4. But then when I looked at the scores that were actually posted when this was done for the real time, it looks like a lot of people, most people kind of got stuck there. I think most of the best scores were in the 500s, 600s. So yeah, not too bad. I should make a point sometimes of looking at the scores that were achieved before I attempt the case, so I have some sense of what's achievable within the time. So yeah, anyway, I think that's enough little introduction. As usual, usual caveats, I've gone through the case a number of times now, so I'm doing this based on prior knowledge and which approaches I like and what things I've learnt, and again really just doing this for my own benefit rather than anybody else's. I know there are existing walkthroughs of this case that probably do a better job than I do. Okay, all right, so I think that's enough to say. Let's go to our score sheet, let's join the game, and then let's click start. And let's get on with it. So level 1, how fast does each of the following cars go around the track? Ignore turning speed, power-ups and stint. Assume no pit stops. Round your answer to the nearest second. So in this case, we're just going around all 72 squares, which is actually 7,200 meters. So this is a really simple one. So it's just 7,200 divided by the speed, and we can actually do this as an array and get all of our answers in one formula. And we'll just post these in here to level 1. And then we'll go back to level 2. How fast does each of the following cars go around the track? Ignore pit stops, power-ups and stint. Round your answer to the nearest second. So now we need to understand how much of the track is straight and how much is turning speed. So I'm going to take the track and I'm going to make a copy of it, just so I don't, because I'm going to make some changes to this, so I don't want to ever affect the original, just in case I mess something up. And what I'm going to do is, on this case, I'm ignoring power-ups. So I'm just going to call this basic. This is the basic track, so we're ignoring power-ups. We'll turn all those power-ups to N, and then we don't need to worry about the pit stops. And I think for now that's all we need. And what I'm going to do is I'm going to turn the grid lines on because I just like to do that. And we need to count ifs this range matches these values, and we see our count. And the start, we're going to turn the start to a normal piece of track. So what we find out is we have 60 bits of normal or straight track and 12 turns. So 60 and 12 is all we need to know for this case. So what we're going to say is we're given the speed and we want to know how long it takes. So speed is distance over time. So time is distance over speed. So if we do 100 meters divided by this speed, that would give us the time it takes to do 100 meters, which if we're going at 200 meters per second only takes us half a second, which is pretty quick. But what we need to do is actually no, we don't need to worry about this on this question about the speed limit. That comes up later, but we mustn't forget about that. So each one will take 0.5 seconds, but there are 60 bits of straight track, so we're going to multiply that by 60 in a minute. For this, it's going to be the same thing. Actually, we need 100 divided by the turning speed. But we only have 12 of those, and then we're going to use sum product where we're going to multiply this array, which is the amount of track pieces, but we'll lock that in place by this array, and we get 42. And in case that's not rounded, although in this case, in the example it is, we're going to round that to the nearest integer, and we'll just drag that down and then fill it all the way. And then we're just going to refer to the answers, which is the final column there, and we'll copy that over to our score sheet. And fingers crossed, yep, we've got full marks. So let's carry on. So level 3, how fast does each of the following cars go around the track? Round your answer. Now we're going to include the power up. So when we have a power up, it's a temporary boost in its speed that lasts for it and the next three areas of track. It also applies to turn cells, and the maximum speed of a car is 200 meters per second. So I'm now going to make a copy of the basic track, and we'll call this the boosted track. And what we're going to do is every time we've got a yellow square, we're going to turn that into, we're going to call this power normal, so PN. And we're also going to turn any of the 3 straights after that are also going to become PN. And if there's a turn after our boost, we're going to call that PT. And then I'm going to change this to PN, and for now I'll just change the PS to PT, just so I'm getting the numbers. So I'm just looking for the numbers here. So how many normal track, how many powered up track, and then how many normal turns and how many powered up turns. So 43, 17, 9, and 3. Okay, so we'll go back to our case. I'm going to say 47, 17, 9, and 3. Just going to double check that. 43, 17, 43, 17, 9, and 3. So PT, so powered normal, no, normal, powered normal, turn, powered turn. Okay, let me just check the total. When I add those up, that's 72, which is how many I should have. So let's think about this. So for our normal speed, again, it's still 100 divided by the speed, but we've now got the issue where we could actually have a maximum. So we're going to say maximum, or sorry, the minimum, because we want to cap it at 200 of 200 and G91. And we're going to do the same thing, and we can do the same thing over here for the power. So the 100 divided by the minimum of 200 and the speed, but on this one we're going to have to add the possibility of boost. So our speed, because we're on a boosted term, will be that times 1 plus the power up boost. Okay, and because that looks the same, because our speed is already at 200, so even with boosted it doesn't go any higher, which is why that looks the same, but we shouldn't get the same issue over here. So I'm going to copy those over, but just make sure they're referring to the correct cell. So that should be referring to the speed, and this refers to the boost. So with the boost we see that they are different because it's quicker going through a powered turn rather than normal one, because that multiplied by 10%, 110 is not above 200. And then we're going to do the same thing as before, where we want to take the sum product of the time that it takes to go through each section multiplied by the number of sections locked in place. We get 41.7, which when we round will give us 42. So we'll bring those down, and then we're going to say we want to round that final column to 0 digits, and that gives us our answers. And let's post those in our score sheet, and we got 200, which is good. So let's return, and now we're going to go to level 4, where we add a little bit more complication, because we've got to take into account the stint, which is how far the car can go before it needs to change its tyres or go for a pit stop, and how many laps in total it's going to do. So the first 3 bits are the same as before, but we've got some extra detail here. So now this is the time to map this out into a data table, because there's a couple of different things happening here. So we need to work out, we're going to borrow the formula from level 3. So I'm going to paste this in here. It's going to return some errors because it's going to be pointing to the wrong things. So this should be pointing to the speed, as should this. This is pointing to the boost. And then same for the turn. This is pointing to the turn and the boost. And this is pointing to the wrong cell. So this here should be referencing that. And then that gives us, so that's the time that it would take to do a normal lap. So a normal lap in this car would be 41.857. So I'm going to now make a copy of this for what happens when we have a pit stop. So let's make one more copy of our map. We'll call this pits. And what we're going to do here is we then cut out all of this part of the track. This then becomes a power turn because we are turning, but we're still within a boosted range. And this becomes part of the straight, but not boosted because we've gone through the pit. So we've now got 40, 15, 7 and 3, which when we add them up is 65, which is what we were told at the beginning is the total length. So 40, 15, 7 and 3. So we go to level 4, so we've got 40, 15, 7 and 3. And let's just check this is all referring to the right thing. So that should be referring to the speed. That should be referring to the speed and the boost. That should be referring to the turning speed. And that should be referring to the turning speed and the boost. And this is referring to that already. So the time, if the pits didn't take any time at all, we'd actually be quicker because it's a shorter track, but we then need to add 10 seconds for going through the pit. So we now know the time for going on a normal lap and a pits lap. So now we have to work out how many times are we going through the pits, what are we doing on each lap. So the way I'm going to do this, I'm going to start by doing a sequence of, we need to work out what is the maximum number of laps we might need to do. So the maximum number of laps is the maximum of this range, which is 24. So we'll do a sequence of 24 just to know how far we have to spread our formulas. And then we're actually going to do a sequence of the actual number of laps for this particular iteration. So laps 1 to 10. And what we need to know is we need to know the range at the start of the lap. So how far have we got before we need to go in and change our tyres or refuel or whatever it is. And at the start of the race, it's simply going to be the range they've given us. We have 20,000 metres we can go before we need to do anything. And then we need to know kind of the next time we need to stop. So, and the way I would do this is going, we know that we've got to be able to get through a whole lap plus the 4,100 metres that it takes to get to the pit stop. So if this is less than 7,200 plus 4,100, then we need to pit. Okay, but this is more than that, so we don't need to pit. But the thing, and this is one thing that caught me out on the first time through, we also need to change this to take into account when we're on the final lap, because on the final lap we only need to make it to the end of that lap. We don't need to make it 4,100 meters through to the next lap. So what I'm going to do is adjust my formula here and say if the lap equals the number of total laps, then actually we don't need to go any further. We just go the 7,200. But if it's not the final lap, we need to get an extra 4,100 to get through to the end. So that's whether we need to do a stop or whether we need to pit, basically. So if we pit, so if that is true, well, that's the easy bit. So if that's true, if it's true, then we're going to take this amount of time. If it's false, then we'll take this amount of time. So that's how long it takes to do the lap. So because we didn't pit, we do 41, whereas if we did pit, it'd be 47. And then we need to know what's our range at the end of the lap. So if we have pitted and if we haven't pitted, what is the range? So if we haven't pitted, so if that's false, and this is the easier bit, so I'll do the false bit. If we haven't pitted, then our range is simply going to be whatever it was at the start of the lap minus 7,200. Okay, but if we have pitted, then it's going to be what we had at the start of the lap. Sorry, not what we had at the start of the lap. It's going to be our maximum, and so we better lock that in place, minus 2,400, because after we pit, there's 2,400 left of the lap. So when we pit, we go back up to 20,000 meters, and then when we get to the end of the lap, we've already burnt off 2,400 of that. Okay, so if we don't pit, if we do pit, we're going to start higher, and then we're going to start our next lap with whatever we had at the beginning of this lap. And if we drag that down, we find that on this particular case, we don't need to go into the pits until the third lap. Now something's going wrong here, so I must have not locked a reference. Yep, so I need to lock both of these references to tell us the time that we're actually going to take. So we get 41, 41, 47, 41, and so on. Now this might potentially go as high as the 24th lap. So if we were going more, that's what we'd have to keep doing. But the timings, we only want the timings when the lap is actually past the race. So what I'm going to do here, easiest way to do this will be to say if this number is less than or equal to the total number of laps, then we want this value here, otherwise we don't want anything. And if I drag that all the way down, it doesn't work because I didn't fix something. What did I not do? Is that not registering as a number? Because when this is blank it thinks it is less, so what I need to do is, let's try that a different way. Let's point to the maximum number. There we go. And then we just want to sum this range, and we get 440.5, which when we round will give us our answer. So we're going to say the round of this cell here to 0 places, and we'll take our values, go to our score sheet, and we're not correct. So what have we done wrong? What have I got wrong here? So let's check everything is confident that's correct. That adds up to 65. Let's check our bits. So this power turn, we have 3 power turns, because that's power turn, that's power turn, that's power turn. Straight. So that's 15. So 40, 15, 7 and 3. 40, 15, 7 and 3. Let's just check we're done with our minimums. That's pointing to the right thing. That's pointing to the right thing. If that is less than or equal to 10, that's good. So what have I done wrong? Don't get any mistakes until we get further into it. Have I done a hard reference? That's not a hard reference. Let's try one of these later ones. Can I see any errors that might help me? So question 59 is wrong. Got some errors. Oh, that's suggesting it gets all the way to the end. Is that correct? That's saying I would pit on the last lap, but that can't be true because I have a range of 8,200, so I don't need to pit, so that should be false. So what's gone wrong here? So if that is less than 7,200, then I need to plus. Let's try wrapping that. I don't think this is the issue, but we will try. So what I want to say is, there we go. We haven't locked this cell reference. If I do that down, that should now, hopefully. Yes, there we go. Oh, bit of on the fly debugging. Oh, that was a slight panic there, but panic over. Okay, so get question number level 5. Let's start racing. So we've given a number of laps and a number of races, and we are provided, and we have to say basically who wins, so which number racer wins, and this is based on the races, and we're given various speeds here. So I'm going to use the working I've done here, and because I've not built this as a nice simple let where I have one formula altogether, I'm going to take an approach where I'm actually going to build a separate data table to give me all the possible variations. So I'm going to do a sequence of 100 to represent my races. I'm going to do a horizontal sequence of, now what's the maximum number of laps? Maximum number of laps is 25. So I'll do a sequence of 25. And I need to extend this because this could theoretically go up to 25. And let's make sure that refers to the whole of the 25. Okay, and what I'm going to do is I'm going to take this to, actually I should have made a copy of this just so I don't affect the original work. I'm going to change the data validation on here so I can actually put any number I want in here. And what I'm going to do is, rather than looking up questions, I'm going to look up this number in my racers and return this data here, which luckily is in the exact same structure as we want. So this is now all pointing to the correct thing. The only thing that's missing is some laps. So if I just put a lap number in there, I'll just highlight that's where I'm putting in. I should now be able to get a data table. So let's round this answer here to 0. And then let's select this whole range. And let's create a data table where our row input, now the row is the lap, so we'll point to that cell there. And the racer is that cell. Now we get our times for every single racer for every combination of laps. So let's name these areas. So we'll call these the racers. And we'll call these the laps. And we'll call all of these values the times. Now we've got everything we need to go and answer question 5. So we will build a separate data table here. We will grab, we're going to text split what's in C1 based on a semicolon multiplied by 1, so we're dealing with numbers. So those are our racers, and our laps is 5. So what we're going to do is we're going to index into our times, index times, X matching our racers in racers, and our laps, which is in cell B1, in the X match the laps, which is in B1 and the laps, and that gives me all of the times. And then I want to find the smallest, so I'm going to say X lookup, because obviously less time is quicker and better, so obviously they have to be more than 0. So let's look up 0 in this array, returning this array, but then matching mode from exact match or next larger, and that gives us number 13 as the winner, which matches the example. We'll copy all of our answers, go to level 5, and we're good to go. Okay, we've got 10 minutes or just under 10 minutes to do the bonuses. So bonus number 1, at what average speed is the time taken to go around the track the same as going around the track with a pit stop? I actually solved this on a post-it note because it's basically a maths equation where what we're saying is if we have 72,000 divided by x, imagine that's underneath, equal to, can't do an equal sign, can I? Yep, equal to 6,500, which is the shorter time divided by x, but plus 10. So to solve this, you basically multiply both sides by x, you get 7,200 equals 6,500 plus 10x, and then you minus 6,500 from 700, so you get 700 equals 10x. And so if 700 equals 10x, then x equals 70, because it's 70 divided by 10. So that's one of those, which is not the first time that's happened. I've seen a question where it's basically a bit of maths. Which racer has ridden the most laps across all the races in level 5? So level 5, let's create a new sheet. Let's grab all the data from level 5, which is this. Let's copy that into our new sheet. And then what we want to do is we want to text split this based on the semicolon, but we'll multiply by 1 so we get numbers. We'll drag those down. Let's shrink these columns. So those are all the racers. Insert a new row. I'm going to do a sequence horizontally of 100 to represent our racers. And what I want to know is when we get a number, if we try and X match these into this range here. So we get a 1, so racer 3 is in that one, and so on. So we get 1s and 0s, and then what we can do is times that by the number of laps. And so we get 11, 11, or 0, 0. Let's drag that down. And then let's do a bicol where we check this array. We sum it up. So we get all the sums, but we're not getting anything because something's gone. Where have we got? Oh, we've not fixed our reference. We need to fix that on W. Fill that down. And now we see all the numbers appearing. And then we want to do the same thing before. We want to find the largest. So let's X look up a really big number. So 9 to the power 9 in this range, returning the racer in this range. And we want exact or next smallest. And we get 63. which we haven't actually put any of these into our score sheet yet. So let's hope we're correct. So we'll do those all at the end. So 63. And for the races in level 5, which race has the greatest potential increase in speed from passing through a power-up? So we're going to go to our racing data. I'm actually going to quickly convert this into a table because it will make this next bit a bit easier. So we know their original speed and we know their power-up boost. So what would their speed be if we apply their power-up boost? So it would be 80 in this case times 1 plus the 8%, but we've still got to apply the fact that this might go over 200, so it's the minimum of 200 and that, and I've just accidentally undone the formula, so minimum of 200 and that. So that's the new speed, and then we want to know the difference between the new speed and the original. And then what we want to do is again find the largest, so let's do an X lookup based on a really large number into this column, returning from this column, and exact match or next lowest, and we get 30, which we'll put into here. Then we'll copy those over to our score sheet, go to the top, paste those in, and just wait the mandatory 3 or 4 seconds we have to wait for it to check our scores. And we've got them all correct, and we've got our 1250 out of 1250, so we can stop solving early. 24 minutes, which with commentary, the commentary probably slows me down by about 20-25%, so definitely doable in under 20 minutes once you know what's coming up. Although, as I said, for context, in the real thing, I mean, we can just double check actually. We can go to the live rankings. This was 2023, and I think I said it was battle number 8. And just give this a second to load. I think you'll find, like I said, I think the scores are all kind of 500-600, so sort of half marks would have been considered very good. So battle 8, yeah, so top score was only 3 players above 600. The next 10 or so were in the 500s and so on. So yeah, getting anything near half marks was pretty much a top 10 finish. So yeah, I quite enjoyed this case. My initial approach, I made it a bit too complicated. What I did originally was I basically tried to get this into effectively a straight line, so I could see. So I actually counted all the spaces using a kind of map. So I sort of did. I set this to be 0, and then did the minimum of everything around it plus 1, and then copied that all across and enabled iterative calculation. I found the distances and then kind of flattened it and put it all into a straight track. I think I was overcomplicating because I thought that the power up boost might change it in its strength at some point, and so having it that way would enable you to look back a certain number of cells and apply the power boost, but actually that was overcomplicating it. So but yeah, interesting. Like I said, there's a couple of other walkthroughs out there which are really helpful to look at different approaches, but yeah, nice enjoyable case, good few things to learn in there. And yeah, if you found that helpful, great. If not, doesn't matter, because like I said, as I always say, I'm only doing this really to help force me to really grapple with the cases and understand exactly what's going on and consider the different approaches available. So thanks for watching.